Not sure how to do this streaming thing, to be fair. Just put it over here, hopefully. It's fine. Yes. Okay, so how do we do this thing? Not sure. This one was really confusing. Just get rid of these, shall we? Right, so question 11 was B. CrCl H2O5 2 plus. So first of all, we already noticed that all of these are going to be Cr3 plus, hopefully. At least the one that I chose was Cr3 plus. All of these are Cr3 plus, okay, no worries. Now, if we picked CrCl and we had 0.1 mole of these, when it would dissolve, then you would have 0.2 of HCl being formed. Why? So my thought was, if AgCl contains only one Cl, therefore 2 Cls would have to be coming from CrCl2, so that 2 AgCls could form, essentially, or double the amount. Solution containing 0.1 mole of these isomers react with silver nitrate. Extra silver nitrate. Now the only other solution, or the only other way of thinking is, okay, fine, so only one Cl atom in AgCl, so you would only have one Cl in the complex. Which, you know, is probably it. Let's just write down our thought process here. So, I also know that you can add in a fill. Fills might be the play. So anyways, let's just go for it. So, wait, are they the play? Let's see. Did I put fill on? I'm confused. What does fill do? Ah, okay. So then I can make it white. Or red or something. Yeah, this is good. I mean, it's a box. Like, I like that. Anyways. This would work the same way as the 1 mole counts in our redox cell questions. Might just be as simple as FCl in HCl, so 1 atom FCl in complex. It doesn't explain why 0.2 mole, why mole was doubled though. Let's actually remove that fill, because it is just, it's kind of distracting, isn't it? Let's make this. What does this look like? Yeah, I mean, this actually does, this, I like this. So where do I put this? It's always the problem. Okay, this does not look nice either. Well, because it makes it kind of hard to read, doesn't it? Hey, whatever. So let's see. I mean, I've been thinking about this already, so I think I'm safe to use AI now. So, safe to use it. Safe to use it. Just in case someone does YouTube, because I know this guy always comes up, either tutorial or advert. How do I do this thing? More videos. So scuffed, bro. Right, sweet. That should be fine. For now, can we just put it on just the... Actually, no, it's fine, whatever. Yeah, it's fine. So let's see, what does AI say? AgNO3 only reacts with chloride ions that are dissociated in the solution. It cannot reach the chlorine atoms that are acting as ligands. So when you're acting as a ligand, you're locked in the complex thing. So it's very hard for AgCl to just do it. AgCl usually will, AgNO3 will usually just do it with free floating Cl- ions, right? So then you analyze the stoichiometry breakdown. Started with 0.1 mole of the complex and ended up with 0.2 mole of AgCl, which gives us a ratio of 2. It tells us that each individual molecule of the complex must release 2 free Cl ions. The total number of chlorine atoms in the hydrated form of CrCl3 6H2O is 3. If 2 chloride ions are free, then only 1 chloride atom. If 2 chloride ions are free, and then only 1 chloride atom has to remain as a ligand inside the brackets. So then it would look like this. Question also asks specifically for the formula of the complex ion. Okay. That's actually very interesting. Okay. So So it does need CrCl2. I mean, it does need 2 Cls, but those Cls have to be outside. And so you would only have to have 1 Cl inside. And so the formula of that complex ion actually would be CrCl. So you imagine it just takes 2 Cls out. So then you're left with CrCl, not CrCl2. Okay, cool. Next question. These are fine. These are fine. That whole question was good. This was fine. This was fine. You just need to mention repulsion being... You just need to mention repulsion, really. It's not really that big of a deal. We have... shuffling of electrons to maintain stability as paired electrons repel. Gaussian always relates to stability. Always mention it. Okay, this one was just a bit unfortunate. Giving data was fine, but had to calculate and show that E cells were all positive. Mentioning it give 1 mark. This question, okay, this is important, like practically, just a little CO2 production is not a safety hazard. However, allowing ventilation is fine. This is good, this is good. Over here, okay, this is good. So first of all, what was the problem with this? The problem was, okay. Um, that's it. That was this paper. Alrighty. Will I get in trouble? I don't think so, since most of it is just same thing. Yo, this text is old news, bro. We could change it. And lastly, perhaps So currently we are on what? We are on Jan 16, I believe. Okay. We're only on 2017, so that's we're just there almost. Home run. Yeah. So let's just quickly go over again the same thing. So this is easy. This is easy. This is easy. Yeah. Trick question. Just pay attention. This. Yep. You just pay attention. I mean, well, no, not really. Now you know how that works. I got this whole. Whoa! What is in my hair? Got dirt in my hair. Up here, mention repulsion, but the overall concept is correct. Show the calculations here. Know the colors. Okay, fine. We can just quickly do that. So, what are we doing? Do you look at this one? I believe so. Okay, to be fair, CR6 Plus is not really very obvious. CR3 Plus should be obvious. CR3 Plus should be very obvious. We know it's orange to green, but like, okay, I did kind of forget, but you should really have that in your brain. Okay, let's see. Do we know CR3 Plus is green, MN2 Plus is pink. I'm pretty sure that turns to. Is it pink to colorless or pink to? I don't remember what I said. Off-white? Yeah. Okay, nice. FE2 Plus is going to be. Is it gonna be blue? FE3 Plus is green. All right. CO2 Plus is gonna be pink. That turns blue, and yeah. Okay. Actually, I have no idea. Wish I wrote them somewhere here. Color. Oh, this is such a good song. This was a long time ago. Okay, it is pink. So which ones are going to be different, right? Those are the ones that you should probably be paying attention to. So this is going to be pale green, so this is all good. Off-white and pink. So this is pretty important. So it's like, yeah. This is pale pink or Carlos. And then CRC Plus, this is going to be green to green, so that's fine. So like, okay, so you can say like, hey, there's a difference here. There's a difference here, because that's going to be pink and that's going to be blue. FE3 Plus to red brown. So FE3 Plus we said was going to be yellow brown. So there's also a difference here. Well, no, actually no, I'm not going to consider that difference. And then there's pink, cobalt. Nickel is going to be green to green, so that's fine. C2 Plus is going to be blue to blue, that's fine. Xeon is going to be colors to white, so that's fine. So where there's differences is going to be in, as we already know, MN2 Plus and cobalt. Those are the only two. FE3 Plus is going to be yellow brown. CR3 Plus is going to be green. CR6 plus is going to be orange. So when we go from CR07 to CR3 plus, right, that's going to be orange to green. Yes. And then from CR3 plus to CR2 plus, that's going to be green to blue. Yeah. So that's it. That's perfect. That's all I really need to keep caring about right now. I mean, it does say that, I mean, I did say that maybe you should do it, but it's okay. Practically, a little bit of carbon dioxide production is not a safety hazard. However, allowing ventilation is also good. Ventilation, okay, so having some kind of mechanism for produced gases to get it to escape is called ventilation. Okay. In the previous past paper, there was something that we learned about like ventilation. I remember there was like some kind of mechanism. Yeah. So over here. Finish into type of question. When regarding any, so this is used to release any pressure that gets built up. Pay attention to the type of equation being asked for. H2 gas is being produced. This was the first one. When regarding any practical questions, pay attention if any gas is being produced in the system because it'll probably be relevant. Because in this case, it was, like even then, I was just like, okay, H2 gas is being produced. Maybe that's going to be a problem, and the pressure. That's immediately what they're referring to here. These are okay. Over here, yeah, just pay attention to the redox equations, and also mention if the concentration is too low, then it might cause we might need multiple burette refillings, which is going to cause problems in terms of accuracy. So we're going to want to have a higher concentration of KMNO4. Simple. It's as easy as that. Oh shit, that is actually a lot of papers now. Because it's going to be October now, so 1, 2, 3, 4, 5, 6, 7, 8, 9 papers. I don't think I can complete 9 papers. 9 papers is crazy work. Okay, never mind, 2016 October, I don't have this. Okay, let's keep going then. Haha, easy. Okay, I should mark it somewhere. 2016 October, was that? Yeah. 2016 October. This one? Yeah, I can do this one. So, questions go here. And MS goes here. Alrighty. I saw it like 2 a.m. so I was like, I'm never really gonna be active for this. I wake up at like Fudger and these guys are on VC, so it's like, you know. The thinker. The thinker, the thinker, the thinker. Oh my god, you're wearing a fedora. God bless your soul. Yep. Alright, so could not be for transition metal. This should be easy. We just want to see where there is a big hit up. So that's obviously going to be this one. The bonding within the complex ion is, so you have data bonding, you have covalent bonding. What's up? I don't think we'll have ionic. Yeah. Dative and covalent. An aqueous solution of transition metal ion formed. An aqueous solution formed a green precipitate with both ammonia and sodium hydroxide. Okay. Green precipitate dissolved to form a blue solution with excess ammonia. So that's gonna be crap. I'm not sure with excess ammonia. That is probably going to be not copper. That's probably iron, isn't it? Nickel, Nicolides. Those are not Nicolides. Alright, it's definitely not this. Fe2 plus, what did we say it was? Green and Fe2 plus and Fe3 plus don't form anything in excess ammonia, I'm pretty sure. So it's nickel. When aqueous sodium hydroxide is added to solution containing manganese 2 ions. Okay. So it then turns brown. That's going to be oxidation. These two reactions show that, okay, so Al2O3 reacts with 6H plus, Al2O3 reacts with 2OH minus, so it can act as, over here it's going to be acting as a base. Okay, wait, hold on, I need to make sure this is correct. Al is going to be minus 6 plus 3 here and plus 3 here. So it's not an oxidizing agent because it's not getting reduced, correct? Over here it's going to be 3 over here as well, so it's definitely not an oxidizing agent. Molecular formula? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, C9, then 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And yep, C9, H10. Oh, who's doing that for funsies? Okay, let's see, where is the rest? Well, not that many questions for that this time around, no? Lina lol. Okay, over here. So in methanol, oxygen, fuel cell methanol is. So, okay, we know that oxygen is usually going to be the thing that oxidized by oxygen. So oxygen is getting reduced. Methanol is being oxidized. Now, where is it going to be oxidized at? Anox. Pretty sure it's anox. It's always anox. But we'll see if I'm wrong. Might be the other way around this time. Copper 2 ions oxidize titanium 2 ions. Relevant half equations is this. E cell is this. Standard potential electrode for this is standard electrode potential. So that's going to be okay. So that shows it being reduced. That shows it being reduced as well. Oh no, it says right here. So copper 2 oxidizes titanium. So titanium is going to get oxidized and this is going to get reduced. So this is the right way, this will be this other way. So we can say that 0.34 minus x is equal to 0.71. So x equals to 0.71 minus 0.34 and the negative of that, so negative 0.37. So they just check 0.34 minus 0, plus, it'll be minus, yeah, 0.37, that'll be 0.71, yep, sweet. Reaction is about this. Which of these reactions are thermodynamically feasible under standard conditions? So this is just annoying, isn't it? So Fe2 plus to Fe3 plus, this is being oxidized. Br0 to Br minus is being reduced. So 1.09 Fe2 plus to Fe3 plus, so that'll be minus 0.77. So 0.3, that'll be feasible. So that'll be P is feasible, so we'll only be looking at these two. So we just need to look at Q. So still the same now we're looking at Fe2 plus to Fe3 plus, so minus 0.77. I is getting reduced, so there'll be 0.54. This is obviously not going to be feasible. No, it is. Wait, no. Hold on. No. It's negative 0.77. If it gets oxidized, it's negative 0.77. So it'll be 0. Okay, so it'll be, now if you look at S, Fe3 plus to Fe2 plus, this is being reduced, and I minus to I, that's going to be oxidized. And so we'll have 0.77 and minus 0.44, which is going to be positive, so it's going to be this one. The volumes and used total percentage uncertainty and total percentage uncertainty on volume measured by burette and measured by pipette. So you know burette is going to be measured twice, pipette is going to be measured once. So then we're going to have 21.8. I'm sorry, we're going to be having 0.05, that'll be 0.1. So that'll be 0.45, so one of these two. And then that'll be 0.06 divided by 25 times 100, that'll be 0.24. So that's going to be this one. Sulfuryl chloride reacts with water to give a mixture of sulfuric acid and NaCl. How many moles of NaOH is needed to neutralize the solution by adding 1 mole of sulfuryl chloride to excess water? So if yeah, so if it's 2 NaOH that's required to neutralize SO4, right? Because you need NaSO4, which is going to be 2 NaSO4, or Na2SO4 rather. So you would need 2 molecules for this and 1 molecule for this. So you need 3 in total. That's my guess. Alright, we're gonna take a break because I gotta go pray. Okay, see you. See ya.
Void's coming after you, pal.
Oh, really?
Ich hat ein gut Traum. Es war interessant, weil ich weil jung Mädchen hat, die ich sich kümmern muss weil sie nirgendwo kam.
Those who know. Alright, let's go. What are we doing? We just finished with these, yeah? Okay. This is fine. Alright, here we go. So, okay, scandium is gonna be just this, this, and this. Mn3 plus, so Mn is gonna be 1, 2, 3, 5, 5. So then you remove 2, you remove 3. So this is gonna go and one of these is gonna go. So you're gonna be having okay, and Fe2 plus is going to be 6, so then that's just gonna be, oops, what am I doing? Okay. Scandium, iron, manganese are Debug element, but only iron and manganese are transition. Explain the meanings of these terms. Where the electron gained enters the d orbital, or we can say the 3D subshell. And transition metals are elements, d block elements that form stable ions with a partially filled 3D subshell. Explain in terms of electron configuration why Fe2 plus are readily oxidized to Fe3 plus and Mn2 plus are not readily oxidized to Mn3 plus. So, Oh, what am I listening to, bro? So arsenic 3 is oxidized to arsenic 5. Okay, so you should immediately know that, see, 3 to 5, so it's going to be giving 2 electrons. Okay, all right. Now in our previous question, if you remember, we said that Cr3 plus was going to Cr6 plus, right? No, with Cr2 plus going to Cr6 plus. So then we would imagine, okay, so it's just gaining 5 electrons. But it's a little bit more confusing than that, because it actually was gaining 8 electrons because of some, because of the redox reactions. So let's look at the redox reactions here and just check, okay? So just to be sure, so we said AS203. So AS is also, what is AS? AS is a transition level? Okay. Perhaps we were looking for S203, not AS203, I'm not sure. S2O3 over here. Gets turned to S2O5. S2O3 gets turned into S2O5. Alright, so since I'm not seeing anything, I'm just going to go with my original understanding. So plus 2, so it goes to there, okay? Oh, and it's already here, you can see. Okay, sweet. I think I get it. So, yeah, okay, sweet. So therefore, this is plus 2. So 2 electrons are being given off, okay? And so MnO4 has to grab them, but MnO4 wants how many? MnO4 wants 5. So we need 5 over here. Okay. However, you see over here that 4 electrons are being present. So it's not 2, it's 4. Now, the point of this is that we see that we multiply this by 5 and we multiply this by 4 so that they're equal. Now, we know MnO4 requires 5 electrons. Yes, okay, cool. So, yeah, so that's why you need 5 moles over here and 4 moles over here. Now, we have to deduce the final thing. So, I mean, shouldn't it be obvious? We see 5, so MnO4 will go to Mn2+. Deduce the final to explain your reasoning. So, okay, so we can say how do we even explain this? Is it 2 marks? Okay, so this should be enough, right? 2 dative bonds with a cation that has using draw the structures of 2 bidentate ligands in oxaliplatin. So over here we have oxaliplatin used in the treatment of cancer. Consists of platinum ion linked to 2 different bidentate ligands. Yep, complex can be represented by the structure. So we have 2 bidentate ligands over here. Okay, and it's gonna form like this kind of square planar kind of thing. I don't know if it's square planar though. I'm pretty sure it's tetrahedral. So, actually no, I think this is the only square planar one. I'm not exactly sure though. Anyways, structures of the 2 bidentate ligands. Okay, so we just want to draw them separately. So one is going to be this is neutral. This is not neutral. Probably they want the lone pair to be showing. So over here, since we only have one, which is going to be 2 minus, I'm guessing it's going to be BD2 plus. Okay. Amino acid synthesis. I don't need to do this as much as I want to. Section C question? Damn, okay, finally. So there are many compounds that contain an element plus 6. When 6 of the element's electrons are used in bonding, similarities exist between these ones. The ions have corresponding formula. The ions with corresponding formula have same shape. Other transition metal compounds exist with the metal in oxidation state plus 6. Between sulfur and chromium. That's how much. Draw a dot and cross diagram for the sulfate ion. This is crazy. Do I know how to draw it? How do you draw a Dawn Cross deck? Alright. So sulfur is 4, oxygen has 6, right? So does it form double bonds? I have no idea. I really don't. This cannot be correct, bro. It cannot. There's no way. There's a 1, there's a 2. Oh yeah, 1's over here. There. And this, and this. This, 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 this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Why is there 16 here? Okay, I'm being dumb. This shouldn't be that difficult, yeah. We know there are 4 electrons, so what if I just said 1, 2, 3, 4, and then they said like 1, 2, 3, 4. Now we have 8, yeah, 2 4s are 8, and then these guys have 1, 2, 3, 4, 1, 2, 3, 4, 5, and then 6. That's the issue now. Okay, I mean, yeah, let's just do that. This makes more sense than anything else that I can conjure up with right now. Oops. No, I mean open that one. I meant to open this one. Crazy thing to. Okay, I want to do this one. Is it just bunches of remixes of them, or no? So true. Funny how it seems always. It's hilarious. Boom, doo, doo, boom, doo, doo, boom, doo, doo. So now, okay, if oxygen was doing the can oxygen have more than the thing? But it doesn't have a d orbital. Let's say it had 2 lone pairs over here, and then it did 4 double bonds. So then boom, boom. What is 3, 4, 5, 6, 7, 8? Yeah, okay. So all these are single bonds. These get removed. I have no clue, bro. Oh god, I swear I had the same problem last year during Unit 1. Oh god damn, bro. It's so annoying. So incredibly annoying. 2 lone pairs of Kitagbe. Wow, that is just so annoying, dude. SO42 minus dot cross. Oh, 2 minus, bro, I totally forgot. What the hell? Bruh. So an electron is given here, an electron is given here. For these two, however, we don't follow this, right? Oh god, I'm so freaking annoyed, bro. Alright, so Sulfur does not have 4. Sulfur has 6. I love chemistry. I love this part of chemistry. The freaking man. God, I'm so annoyed. It's basically elementary stuff, which always just annoys me so much. Anyways, whatever. So you have 6 electrons in sulfur, right? So oxygen is gonna give 1, 1, 2, 2, right? 1, 2, 3, 4, 5, 6. This boy is gonna give it 1, 1. That's 4 already. That's 8 already in oxygen. And then it's gonna have 1 here, and then double here and double here, electron. 1, double here, double here, double here, double here. This is gonna have only single double. Always believing. Always believing. So no lone pairs here. Since no lone pairs, this is gonna be square planar. It feels weird to say that, but let's just see. Lead 2 sulfate mixed with this much water. Calculate the mass of undissolved in this mixture. So this much mole in 1 dm cube of water. So how much in this many dm cube of water? That's basically what they're saying. So first of all, 250 centimeter cube is going to equals to 250 times 10 to the power minus 3, which is going to be 0.25 dm cube, right? Okay. I have 1.26 times 10 to the power minus 4 is to 1. So then if we divide both, or rather multiply both with 0.25, indestructible, always believing. Mm-hmm. 3.15 times 10 to the power minus 5 moles. Okay. Now we know this much will dissolve in this much water. Okay. Now we're trying to find out the mass of the undissolved. Cool. So first of all, how much is the mole? Yes, I'm gonna go in 1 minute. Oh god, so annoying, dude. All right, times 0.05. 303.3 times. Whatever, bro. 0.05. We're trying to find out the number of moles, so we're going to divide 0.05 by this. So so we're getting 1.6485 times 10 to the power minus 4 mole in total. This is the amount which dissolved, so then ounce minus 3.15 times 10 to the power minus 5 is equals to 1.334 times 10 to the power minus 4 mole. And so then we're just going to find out the mass of this. So an ounce times 303.3. Sodium disulfate decomposes on heating to form only two products, sodium sulfate and an oxide of sulfur. Our equation for this decomposition. So sodium disulfate decomposes. So Na2 okay, wait, hold on. Is that really? Because I'm like sodium dichromate. That's like Cr2O7. You know what I mean? I mean, it's usually going to be like this. See, this is sodium sulfate. Okay, fine, cool. Sodium disulfate. It's the same oxidation state. Oh. Six. SO3 minus, right? SO4 minus. Sulfate is 4. Am I going crazy? I'm going crazy. I'm going crazy. Oh my days, bro. Right? So that's sodium sulfate. And oxide of sulfate in oxidation state 6. This is also the same as these. So right? So this is gonna be 8 oxygens. Here's 4 oxygens. Here's 3, 7. Here's 4 sodiums. I don't think this is sodium disulfide, bro. I'm gonna be completely honest with you. Is sodium disulfide given? Oh, it is, isn't it? Sodium S2O7 2 minus, okay. Na2 S2O7, what did it say? 2 minus? So you can remove that. Okay, so now we have Na2 S2, and then over here we have 4, and we have, so is the problem. Sulfur and oxidation. Okay, so it's not going to be SO3, right? Obviously, we need to have 3 oxygens, but S needs to be 2. No, it's already, yeah, this is already fine. 2 S's, 7 oxygens, 2 NAs. Okay, this is it. So ammonium dichromate decomposes on heating to form chromium trioxide, nitrogen and water. So this is going to be Cr2O7, we know 2 minus, so then we're going to be having NH4 2, okay, because we know it's NH4 plus, we need 2 of them. So NH4 2 Cr2O7 decomposes on heating to form chromium 3 oxide. So that's going to be Cr perhaps. Would that be it? 2 minus, no. Can we do Cr2 minus, right? That would be 4. And if I do 3 plus, and then they'll leave it as 1 minus. So, okay, perfect. Then nitrogen and H2O. Okay, let's see. So, N2, H8. So we need 8 over here. Cr2. Okay, first of all, it says Cr2, so let's put in Cr2 over here. H is not done yet either, but H only has 1 source, and it says 8 over there, so we need to put 4 over there. Oh, I hate this. Okay. It's not gonna be this chromium oxide, I don't think. Chromium 3 oxide. ARM. Two nitrogens, 8 hydrogens. 2 nitrogens, 4 over here, 8. Okay, could it also be CrO3? And I have 2 minus. CrO3 is 6. And if I have 3, that will be 3 minus. Could it be CrO? And I have CrO plus. They did not say it was an ion though. Chromium 3 oxide. Okay, one thing is for sure is that this has to be 4. right? If this is 4, then we know that over here there's going to be 4 oxygens. So we therefore know that over here there needs to be 3 oxygens, no matter what. So therefore, but then we also know that there's going to be CR2 over there. Yo, I have literally no clue. Alright, whatever, moving on. Complete the table using page 14 of the data booklet. Page 14. CR2042 minus. That's going to be minus 8 plus plus 6. Plus 6, CR2042 minus, that'll be plus 3, and 4 oxygens. So let's see, CR2042 minus. Now we have 2 chromiums. So no need for that. We have 4 oxygens, which is a problem. Which is a problem. Wait. Am I dumb? No. Why is this a problem? Because if we have CR2, there'll be 4, which is 4 oxygens here. So we need 3 oxygens, but we're not getting 3 oxygens from here because that would be 3 times 2 is 6. 6 hydrogens, but we need 8 hydrogens. Could I write plus H2? I mean plus 2H plus? Is that possible? Do you got that? Whatever, I'll risk it for the biscuit. So I'll write in 3 over here, plus 2H plus. Okay? So yo, what am I listening to, dog? It is given the data booklet. I mean the other part. CR042 minus. Nope. Yo, why is this paper so much more difficult than the other ones? Okay. Let's quickly just do this. So we see that CR goes from minus 8 6 3 plus to CR is 3, that's gonna be 3 plus, so no electrons are gonna be released. Okay, no, but you have 2 minus over there and minus over there, so there has to be plus 3H plus or plus 2E minus on the left, plus 2E minus on the left, 3E minus on the left, so plus 3E minus CrOH3 plus 5OH minus, and this is going to be minus 0.13. Give the formula of the species which under the standard conditions is the strongest oxidizing agent. Strongest oxidizing agents. The most negative one. SO3 2 minus. Disproportionation of manganate 5 6. So MnO4 2 minus. So what do they form? What are the two things that they can form? They can form MnO2. That's going to be 6, right? That'll be 8. Yeah, that's 6. MnO2 and MnO4 minus. So this requires 2 electrons, this requires 1 electron. So I can write in like plus 2e over here, and then plus e minus over here. So I can cut this out and write this. Nope, I'm dumb. Am I dumb? No, I'm not dumb. This is what I got, because we see MnO4 2 minus reacting with 2H2O and 2 electrons to form these two. We also have MnO4 2 minus reacting to release an electron and MnO4 minus. So we're going to be having MnO4 minus this and this. Electron cancels, so you have 1 electron here. If I did say 2 over here, the problem is with that is that so we could remove this and we could just write 2 MnO4 minus. So now the problem is, you can see the problem three MNs, we have 4 hydrogens, 2 plus 12, 14 oxygens. We have 2 plus 8, 10, 14 oxygens, and we have 3 amines. Okay. Now, what about charge balance? We have 2 minus on the left, we have 3 minus on the right. If I didn't write 3 and 2, what would happen? So again, how many hydrogens? 4, 4. How many oxygens? 2, 6. Over here is 2, 6, this. 2, 6 this. But after this, we have 2, 12, 14, 2, 8, 10, 12, 14, sorry. So, okay, it is plus C minus over here. Because that would be 3, 2 minus... Oh, no, not even close. What am I talking about? This is going to be 2 minus, 4 minus, so that'll be 6 minus. No, mine's balanced. Alright, I'm just gonna look at the market scheme because I don't have time for this. Ah, come on, I can just do this. Where is it? So MNO4 minus. Let's go down. So MNO4 minus to MN2 plus. That's gonna be 1.51 because we see it. This is the forward reaction. Then minus by what? Minus by the H2O2 reaction. It's H2O forming H2O2? No, H2O2. H2O2 forming O2 and H plus ions. We see H2O there as well. Is it disproportionating? I think it is. Yeah. Yep. Might be. Oh shit. Doesn't that mess up the calculations a bit? No. Isn't the water coming from the other reaction? Let's see. 4 H2O. 5 MnO4 8 plus 8 plus 5B minus. Mn2 plus. It says right there 2 Mn2 plus. Therefore we'll have 8 H2O. Okay, yeah, done. So therefore that would be H2O2 minus 0.68. So that'll be 0.83. Used to determine the standard electrode, the diagram of the apparatus you would use to determine the standard electrode potential of dichromate Cr3 plus using a standard hydrogen electrode. The whole thing, I don't understand what they mean by that. Fully labeled diagram of the apparatus you would use to determine the standard electrode potential of dichromate, this electrode. Okay, whatever. I'm pretty sure they mean both then. So, okay. Oh, we gotta be careful. Because that's gonna be a platinum electrode, right? This is gonna be a KNO3 salt bridge. This is gonna be wire. This is gonna be porous platinum. It's gonna be 1 mole DiM cube HCl solution. Okay. If we use this dichromate, so there'll have to be two of this and one of that. I'm pretty sure. Okay, so 2 mole, just 2M Cr3 plus solution, and 1 Cr2O72 minus solution. Anything else? I don't think so. Use the equation to determine the mole ratio of S2O3 to Cr2O7. So okay, over here it's 2 to 1, so just 2 to 1, and then it's gonna be 3 to 1, and then that's it. I don't need to do anything else, because that would be to something else. We don't need to do that. So therefore this will be 3, this will be 6, so it'll be 6 2. 6 to 1. 6 mole S2O3 2 minus 2 1 mole Cr2O7 2 minus. Okay. Now I'll calculate the mass of ethanol in 5 centimeter cube of the original white wine. So you think I can do this? I don't know, man. Anyways, 9.2 times 10 to the power minus 3 times 0.03 mole per dm cube. Okay, now divided by 2 divided by 3 times by the thing, which is going to be ten centimeter cube was added gone for glass with 1 centimeter cube of the diluted white wine. How much is taken out? Oh, god damn, I suck at this so much. Okay. Okay. I think I remember. So 4.6 times 10 to the power minus 5 mole in whatever. Yes. Then 10 centimeter cube of this, of concentration this, was placed into the conical flask with 1 centimeter cube of diluted wine, left as well. added to the flask to react with the remaining. Okay, so this is the amount mole that reacted, and we should see how much there was at the beginning. So man, I'm not so bad at this, bro. I'm crashing out, bros. I'm crashing out. Crashing out. Wait, relax. Um, 10 centimeter cube. Ki I minus. Okay, 9.2 times 10 to the power minus 3 times 0.03. Times half. That is the amount that is left. Okay? Which means that that would be therefore we can find out the amount that was left. No, because it's I2. So it's I2. Can use how much dichromate was reacted. But this dichromate is actually what is left of this reaction. Okay? So let's just do this. Again, 9.2 times 10 to the power minus 3. So 4.6 times 10 to the power minus 5. So 4.6 to the power minus 5 mole remaining. So how much was there in the first reaction? This reaction. Okay, so we have 5 centimeter cube of white wine, which is diluted to this. 10 centimeter cube of potassium dichromate added in. Because that's going to be oxidizing agent, so that provides the H plus ions. More remaining of dichromate. So that means dichromate was the excess, and the thing was limiting was this. So originally we can see that there was 10 centimeter cubes, so that'll be 10 times 10 to the power minus 3 times 0.015 mole. So there was 1.5 times 10 to the power minus 4 initially. So used up was 4. ans minus 4.6 to the power minus 5. 1.04 times 10 to the power minus 4. Okay. That should be in a 3/2 ratio. Divided by, or times by 3/2 rather. So we just do ans times 3/2. 1.56 times 10 to the power minus 4 mole. So this is of this thingy, right? Okay, note here. It says 1 centimeter cube of the diluted white wine, which means that they took it from the 105 whole thing into the 1 centimeter cube thing. I'm pretty sure. So now this that we're reacting with, this is in 105 centimeter cube. So then I need to, this is in, crap. This isn't the 1 centimeter cube. So then I need to do 105 divided by 1. So I have to multiply this by 105. 105 or 100? I think it's 100, not 105. Because we usually, but when we say 1 centimeter cube of diluted white wine, we're including the white wine. Whatever, bro. So this times our MR of white wine. 12 times 2 plus 5 plus 1 plus 16. 0.75 mass of ethanol. 0.75 what? Grams. Oh, they're asking 5 centimeter cube of the original white wine. Yeah, that's it. We just undiluted it. Naki. Yeah. This was the amount of moles in the 105 centimeter cube, which is fine. So it's still 5 centimeter cubes. Is it? Okay. 0.75 grams, that's what I'm getting. Let's see. Zero 0.71, 0.72. Close. Okay. Did they multiply by 105? That might be the reason why. Yeah, they didn't. 1.56 times 10 to the power minus 4. Yeah. And then they multiplied by 100. Not 105. TE on the... Okay. Okay. TE on that. T on the 5. Okay. So I should be getting it. Nice. T on everything, bruh. It's funny as hell. Alright, cool. So I'd be getting like 5 marks or whatever. This is 6 to 1. Has to be, obviously. Alright, cool. Okay, notice, okay, that over here, it's since you have to just do this, okay? Diluted with how much water? You do it's diluted to 100 centimeter cube. It's a 100 centimeter cube of distilled water. So this is the total solution. Okay, that's my bad, but it's okay. This is a freaking hard paper, bro. God damn, this is really hard, bro. All right, D, A, D, D, B, B. That's it. 16 A. Nice, by the way. 17 A. 18 B. 19 C. 20 D. Okay. So it's not C. Incorrect value. Thank you, bro. How many moles is needed? Okay, so that's what I was thinking, right? So H2SO4 would require what? It's a diprotic acid, right? So it would require 2 moles of base. So then I was like, okay, fine, 2 moles of base for this bad boy. HCl is monoprotic, so that would be 1 mole of base. How many moles of NaOH are needed to neutralize the solution by adding 1 mole of sulfuric chloride to this? It's more than I thought. That's funny. Oh, okay. Is it 2HCl? Because there's Cl2. There's that 2HCl. Yeah, it is. Pretty sure. 2HCl and then just 1 H2SO4. Because there's going to be SO2. 2 oxygen is coming from H2O. That's kind of dumb, isn't it? Okay. I could just pay more attention to the things. A lot of the times, a lot of the marks are being lost for me not paying attention. So like when I'm confused, I just have to pay attention, but I'm not doing that for some reason. Yup. Elements. Last electron goes into the d subshell. One of the orbitals, an orbital. Electron gain enters the 3D subshell. Valence electron is not allowed. Okay. Remember last electron. Transition metal forms at least 1 ion with what? Penized shell for subshell. Okay. Forms D-block elements that form stable ions with a partially incomplete or partially filled 3D subshell. Nice. Okay. Either or. Okay. So either these two or these two. So half-filled 3D subshell is stable due to electron repulsions. I don't think any of those. Okay. Fe2 plus gets oxidized. Half-filled is stable. Fe3 plus and Mn2 plus both have 3D region half-filled orbitals. I hate marking these questions, man. Because I have the right idea. It's just how I'm supposed to write it, which I just don't care. Okay. It's not stable due to electron-electron repulsion. The others are unstable due to electron-electron repulsion. This is stable due to a lack of repulsion or minimized repulsions. So yeah, if I said minimized, then that would be fine. Anyways, I'm not gonna be stuck on this. Different oxidation states Energy difference between sets or splitting of 3D orbitals is different when is different. So they absorb different frequencies of wavelengths of light. Okay. About AS, 5 moles oxidized, so change or increase in oxidation is 20 total 20 electrons lost. 5 moles releases 20 moles of electrons. 4 moles, so 20 electrons gained. So change in oxidation number for each is 5. Each Mn04 minus. It's not this, bro. It's the freaking. It's the ion. It's Mn7. Okay, you write Mn7 here. Mn7 ion. Okay, cool. Okay, compound that form. Okay, has 2 atoms that can form data covalent bonds. Forms 2 data covalent bonds with cation. As using 2 atoms with lone pair. Okay, just 2 atoms that form compound with 2 atoms that form data bonds. That's it. Compound that forms data bonds with cation, but bidentate needs to be there. So 2 data bonds. Forms 2 data bonds. Okay, fine. So this is done. This is done. Nice. 2 plus. Nice. Oh, it is the full thing. Sweet. Okay. All right. Single, those are the ones with the ions. And then double, those are the ones with just 4. Nice. Okay, square planar, so it's tetrahedral. Obviously tetrahedral. Come on. See, why is it tetrahedral? Why is it tetrahedral? I actually have no idea. I don't know why I call myself stupid. I have no idea why it's tetrahedral. It's 4. Does it only form square planar when there's 2 lone pairs? With a separate table. Oh, it does. Oh, yo. It forms tetrahedral when there's 0 lone pairs. That's funny. Alright, noted. Cold. Nice. Nice. Oh, unfortunate. Nice and okay. CR203. I didn't write that. Would that have made sense? Yes. Because that's going to be CR0366. 6 minus 2 is going to be 6 is going to be divided by 2 to be 3. It's no ions, so yeah, CR03 would have been perfect as well, because you have over here 4 oxygens for sure, 2 dichromates for sure, and then the perfect 3 that was required here. Unfortunate, anyways. CrO42 minus plus 4H2O plus 3E minus CrOH3 5OH. I forgot to give the states here. This has no state. This is CrOH3. This is going to be a precipitate, so this is going to be solid. This is going to be aqueous. Yes. And yeah. Then SO3 2 minus. Okay, this is wrong. What? Strongest oxidizing agent gets reduced. Oh, that's painful. painful. That is painful. Anyways, I just did the strongest reducing agent because this is the thing that gets oxidized the strongest. Okay. My son, you gotta include state symbols, but you gotta pay attention. It's a waste of time. Let me come back. Let's see. There was something, everything about you. Baby, come back. You put it all on me. I was wrong. Oh, the voltmeter. That is unfortunate. Do you know where this mark of the circle is incorrect? Ignore ammeter and voltmeter. There you go. You were here. Baby, come back. Anywhere I could see. I was loving everything about you. Baby, come back. Do 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 do. You see, come back. Any kind of fool could see I was something, everything about you. Baby, come back. Think it all on me. That was all. I was wrong. God bless her soul, bro. Actually, wait. Oh, we are pretty close to it. Oh. GG. GG. That's a good run. Boop-a-doop-a-doo. What are we doing? Did we just start the next one? Okay, let's review. Real quick. This song genuinely might be the worst song I've ever heard in my entire life. Sorry, old heads who are watching. Alright, what's going on? I think this paper did go well. I mean, like, but I took too long. That's the only problem. Okay, nothing wrong for any of these. Only got one of these wrong, I believe. Yeah. So over here. Okay. Okay, wait. When confused or working off a guess, try to pay attention to the tiny details they're giving. Here, it's reacting with water. Let's do SO4 and HCl. Notice that HCl would have 2 moles. You were halfway with the idea that sulfuric acid is diprotic. Just had to not rush and think about HCl closely as well. Pay attention to the moles and the amounts of atoms in each species. Alright, moving on. Pama. Last electron, this is just definition of D block. Last electron to enters the d orbital. This is basically it. Just be more explicit. Like, be more explicit. Use baby language. Don't overcomplicate simple idea. Both Mn2 plus and Fe 3 plus have half filled. Half filled is more stable. So Mn2 plus doesn't. So I don't want to repeat myself. So Mn2 plus stays by getting oxidized, and Fe2 plus will get oxidized to become more stable. When talking about species gaining or losing electrons, explicitly refer to the ion, not the whole. Okay, over here's learn basic def. Compound with two atoms that form dative bonds with ion. This is fine. These are fine. Okay, for these, okay, first of all, learn vecifer or just have it around. No lone pair. Only square planar when two lone pair. Practice more dot cross with harder examples. These are all correct. This I don't really have a problem with. Okay, in this case, literally both times include state symbols. So pay attention to state symbols. Voltmeter should always be there. This is fine. This is fine. Okay, sweet. Sweetings. Let's see. All right, 2017 June. हाँ Maghrib कौन दिबे तहन যাচ্ছে when I go down for prayer I'll give. Alright, so sir, each of these a transition metal. Um, friggin' titanium. Yes. Wow, we barely touched titanium. Thallium. Um, 0.1. Wow, they're finally giving like actual answers. That's funny. Okay. 0.012 mole of Tl3 plus is oxidized to 0.024 mole iodide ions. What is the oxidation number of thallium ions produced in this reaction? What is going on with my mouse? So it remembers its old position. That's kind of cool, isn't it? Oxidized this many iodide ions. Oxidation number of thallium ions produced in this reaction. So 0.012 to 0.0024. So that's 12 to 24. That's gonna be divided by 6. That'll be 2. Divided by 6. That'll be 3. 6 times 4. That'll be 1 to 2. I'm sorry. This is obvious. 1 to 2. 2 moles of iodide ions. 2 moles of iodide ions means that 2 electrons are released. 2 electrons being released means 2 electrons are being absorbed by thallium. So 2 electrons being absorbed, so that'll be 1 plus. CuH2O6 is blue because the water lag can spin the 3D and 3D electron is part of a higher energy level. Absorbing all but blue light. No, it absorbs. It. What does it do again? It's its complementary color. So reflecting all but I don't know, man. From it to higher energy, absorbing all but blue light as it drops back to its ground state. No. Absorbing all but blue light. Emitting blue light as it drop. No. Emitting all but blue light. This is not what I expected, but okay. Ammonium. I should be spending more time on that question, but I'm not. Ammonium vanadate. Colorless gas. Dissolves in aqueous. This gas gives a pale blue precipitate with copper 2 sulfate. What is the colorless gas? Pale blue precipitate with aqueous copper 2 sulfate. Cu2 plus will make a blue precipitate? Yes. Boom. Boom. I have no idea, dude. I don't know a reaction with aqueous carbon sulfur. However, we'll say if you have NH4 here, NH4 VO3. So it'll probably be like H2O6. And then, since it's plus, so it's going to be only taking one. And so it's going to be releasing hydrogen gas? Hold on, no. It's going to be releasing one H2O. It'll be OH, then H2O5. Okay, so I didn't know it releases a colorless gas. I don't know what this colorless gas is. Gives a pale blue precipitate with aqueous copper disulfate. I'm also not familiar with this reaction. If I were to guess, pale blue precipitate with copper 2 would probably be the copper 2 hydroxide. And how would you get a copper 2 hydroxide with this? We have a salt and we have a base. So I don't know, man. I'm just gonna give this. I have no idea. I'm really tired, dude. I can't keep working. I can't do it. Oh shit, dude. Oh. And as if I'm not prepared. Just got 7 likes, little bro. Get good. Who you are? It's the freaking Minamo monster. Yep. But you're not gonna freaking follow me, aren't you? No, you little shit. Whoa! Wait, this is kind of cool. Who are you? Did you follow? Okay. Do you follow anybody else I know? How did you find me, little bro? Who knows? I don't. So true. Kawaii with a touch of shiny darkness.
Glasses over here.
No.
My glasses.
Thank you, dude.
When the baby girl buried alive is asked for what sin she was killed, this is the ayah from the Quran which has haunted me for the past few days, and I think it exposes something sinister about how we think about societal progress. You see, the context of that verse refers to the barbaric practice of female infanticide in pre-Islamic Arabia, where effectively the birthing of a baby girl was seen as dishonorable, so these pagan tribes would just end up burying them alive. And in many ways, Islam presents itself as the antidote to this backwards behavior. It came to restore the sanctity of women. That's why you hear the Prophet Muhammad, peace be upon him, talk about how heaven is promised to the fathers who raise little girls. And this is why Islamic scholars call it the age of Jahiliyyah, or the age of
Yep, coming.
now, interestingly, when you read modern secular scholarship on this, they say something quite different to the Islamic tradition. They actually say that this wasn't really an age of moral decadence, rather, this was quite an exaggerated claim. To be honest, they really just base this off the fact that art, culture, poetry, trade, and commerce flourished in these times when there was great cultural and material progress. And if you're thinking about that tension and the difference of living across that moral, cultural, and material understanding of pre-Islamic Arabia. And honestly, I can't help but notice the historical parallels to the modern day.
This is day 10 of donating 24 million meals to people in need. For this video, tag your favorite food brand in the comments because realistically, I can't do this alone without a partner. Last video, you guys racked up 3,000 comments, 40,000,
Okay.
raising $1,600.
How I wish to God that you were here. Baby, come back. Do, do, do. Do, 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 do. Do, 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 do. Baby, come back. No, Martin, I'm sorry. Martin. Took a break from anime. Oh my god. It's magic. Could have been blind in one eye. Chemical one-eyed pleasure. Truly. Truly. Masterpiece! 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 Pop it down. Face fuchsia poop shape. Poop shape. I'm gonna go crazy. I'm gonna go crazy right now. It's so difficult to do it all alone. I swear the questions have gotten a bit harder since the last years I was here. Since the last years I was here. Titrated with the solution containing this many ions. This many ions. Bum, 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 bum. Bum, cha, bum, cha, bum, cha, bum, cha, bum, cha, cha, cha. Jabana, bum, cha, 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 bum, cha, 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 bum, cha, cha, cha. CV equals this, so you divide it by constant. This is in the m cube, so you divide by 1 times 10 to the power minus 3. Yes, sorry. I mean, just one light, but okay. Station reach carbon. Carbon. 6 minus 8, 6, 3 to minus 4 plus 4, so plus 1. Obviously not any. Okay, so Ag, so this is, these two are no. Potassium carbonate or potassium nitrate. Probably just nitrate. Carbonate तो क्या नहीं use करबो. That causes phenolphthalein to turn pink. So you can check the table. Case I forgot, 'cause I really did forget. I can't do it's alright. Get that. Jack, jack, bomb, jack, 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 bomb. Jack, jack, ba bomb, ba jack, 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 bomb, jack, 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 bomb. Jack, jack, bomb, jack, bomb, jack. Should not be spending this much time on a question, but I am. This much time on a question, but I am. Copper is the negative electrode, meaning. Ladies. Ladies, man, all ladies, man. I have no idea. If it's a negative electrode, I'm guessing electrons are coming this way. If electrons are coming this way, then solution in the right hand beaker contains suitable electrolyte and phenolphthalein. Okay. Phenolphthalein turns pink when it's alkaline. Okay. So what? So what, Biz? So this one. Do I need to care about anything else? Electrons are. Copper is a negative electrode. What does it mean when I say copper is a negative electrode? Doesn't it mean that does it mean what I think it means, or does it mean what I know it means? I mean, if I say copper and oxygen, it's like generally copper is the thing that Copper is like pretty unreactive now. These aren't taking too much time. Alright, let's look at the next game. So, sir. Yep. 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 Right, this is a transition metals question, so I'm not too worried. 5 is A. 6 is A. 6 is A. 7 is D. 8 is C. Ha 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 ha. So I say negative electrode. It is what I think it means. Yeah. No. It's going towards the right. Oops. So it's that, like, since electrons are coming out, they're going to be depositing. When we say negative electrode, it's like electrons are coming out of here. So that's why this is like the negative, because it's like the source. Makes sense? And because this is the negative electrode, electrons will go to the positive electrode. That was the negative electrode. That wouldn't really necessarily mean that the electrons would be going there. It means it would be going from there to here. Negative means, hey, I want to go to the positive. Strongest reducing agent from here. Strongest reducing agent means it's going to get oxidized. So it's going to be the most negative. So it'll be Cr 2 plus A. Ha 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 ha. Which hydrogens would oxidize chromium 2 to chromium 3 but not chromium 5, 6? So chromium 2 to chromium 3 would oxidize chromium 2 to chromium 3 but not chromium 6. So here we have chromium 6 but not 2 chromium 6. Okay, cool. So this is positive enough to allow both. From here, which one? Oh, okay, here. So we can say I2 and Br2. So D. Information about benzene is not provided by X-ray. Whatever, bro. I don't give a shit about benzene. Benzene is dumb. Benzene is stupid. Stupid. CrCl4, a complex ion, is going to be tetrahedral. Explanation? Because this is the shape that minimizes the electron repulsion. Tetrahedral, 4 pairs of valence electrons. Bond pair, 4 pairs of valence electrons are bond pairs and arranged to minimize repulsion. Precipitate dissolves in excess sodium hydroxide for both reactions. So CrH2O6 plus 3OH minus makes CrOH3 H2O3 plus 3H2O. This would be aqueous solid, aqueous liquid, aqueous solid liquid, and yeah, there you go. This is wrong. What is this? How did they get that? What the hell? What is this? Okay, Interesting. Then CrOH3 plus 3OH minus to make CrOH6 plus 3H2O. This is going to be solid, aqueous, liquid. CrOH3H2O3, solid 3OH minus, OH6, 3 minus, H2O. Yeah. Octavia drugs, this is two isomers, so Cl, NH3, 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 NH3. Okay, that's obviously not it then. NH3, NH3, Cl, NH3, Cl, NH3. And then this is gonna be Cl, NH3, NH3, Cl. Shows the color intensity, complements a form of complex EDTA with a greater color intensity than the complex ion form with cyanide. Sketch on the above axis you would expect to obtain if you increase the amounts of EDTA it was used instead of cyan. Form complex with a greater color intensity. Okay, so would it stop at the same thing? The CN minus ions which do it 6. EDTA does 6 once. So then it would be like here. Or like maybe here. Chromium 3 ions form a neutral complex with bidentate ligand known as ACAC. What? Fatima! এখানে আসো Yo Eval Devilish Are you ready to pray?
If you come with me.
That way.
Come with
I wasn't lying, bro. Look.
I know.
Chromium 3 ions form a neutral complex with the bidentate ligand commonly known as ACAC. ACAC. You're failing chemistry, bro. Don't take chemistry. Bro, you take psychology, bro. If you take psychology, you gotta take bio, and if you take bio, you gotta take chemistry, and if you take chemistry, you gotta take physics, if you take physics, you gotta take math, if you take math, you gotta take business, if you take business, you gotta take Come with me and you'll see. Yeah, you ain't going anywhere, buddy. Come along. Sorry. Bro, wait, bro. Bro, I got a test, bro. What you want me to do?
When do you go to test?
In like 10 minutes, bro.
I hate you.
I hate you. You hate me. Do you know where that's from?
I don't know, you told me.
You don't know where that's from?
I know it from you.
Oh, you don't know what what TV show that's from?
Barney?
Yes.
But I thought you were singing the I Hate You version.
I just wanted to know, like, if you knew where the original version came from.
Shut up, I used to watch Barney all the time.
No, you didn't.
Yes, I did.
Barney was never on the TV.
What do you mean it wasn't on the TV?
Maybe I never
Why
watched it.
Barney?
Because it's just, I don't know, it's like Barney. Like, who didn't know Barney, bruh? I hate you, you hate me. Let's team up and kill Barney with a big, big bomb and a knife. Wait. With a big, big knife and a bomb on his head. Sorry, kids, when Barney's dead. Oh, God, this is so hard! Excuse me.
Do this. I should do like some tapestry work. Yes, I should gather scrap fabric and then I should. Yeah, I should do that. Can I open the door?
I hate
Can I open the
you.
door?
You hate me. Let's team up and kill Barney.
I'm already done.
Big knife and a bomb on his
I hated that song.
What was the last line? Sorry, kids, but Bunny's dead. I have a test. Barney is dead.
It was a mistake, I'm sorry.
It's a mistake, I'm sorry. Oh, God. Oh, wait. But wait, let me show you the better version. Wait.
Don't you give up. Don't give up. It's the way you just
Have you ever seen this video?
No.
Okay. Sorry.
Can I not see it?
Wait. It's so funny, bro. It's so funny, bro. This- Oh my god, you haven't seen it. That's so funny. Flood! No, this is. Okay, we gotta take the actual one.
Then you clicked on the same video.
I didn't.
That was so stupid.
I just don't want to say that you're sorry for now, girl. Guess I just want to be sorry. I know you say that for me. I love to say that you're sorry for me. That's sometimes.
Stop! You don't have the anymore.
So beautiful. Sorry. I'm sorry.
It's so sad.
Did you know?
Like the crowd was trying. No, and the crowd was trying to cheer him up as well.
I'm sorry.
Yeah. Daddy, we're alone. How? Okay. Sorry. Sorry.
As Gomi crossed Gabe-ish dive, she suddenly came across a lone puppy. The puppy was frightened. Unfortunately for her, the puppy was used as bait. Then came the Cherry Hounds. These hounds were hungry for
Whether or not Jar-Anpur is an imperfect country does not give another nation the right to
Yes,
invade.
the Moravian government maintains they're freeing the Jar-Anpurians from a tyrannical regime.
You know that's very silly. The Moravian government of all people is saying this? Come on.
This is on the record, Superman.
Now you're being dishonest, Lois.
I'm being dishonest.
Where's the button? You're being dishonest because you know as well as I do that the Moravian government is not well-intentioned.
That's almost certainly the case, but do I need that? No, I don't. Can we move on now?
Whether or not Jar-Anpur is an imperfect country does not give another nation the right to
Yes, the
invade.
Moravian government maintains they're freeing the Jar-Anpurians from a tyrannical regime.
Cookies look amazing this week. Had it out before next bash.
Yum! Which one ended up being your favorite?
I like the Oreo crumble. Had it out before next bash.
Yum! Which one ended up being your favorite?
I like the Oreo crumble.
fucking top.
Last of Us Studio mobile tutorial. So you guys absolutely love my Last of Us Studio mobile tutorial. So let me show you how I made these out of fire. First I got some simple chords. Got some pads in the background. Then I added this. Time for some 808s. And some bouncy drums. Here's the full beat. So you guys absolutely love my Last of Us Studio.
Yeah. Oopsies. I don't know what I'm doing, man.